I'm using this Chinese pipe bending tool, which allows me to put very tight bends in the copper piping. And the piping is 5/32 of an inch or 4mm pipe. And these are quite tight bends, and it looks okay. The more piping that you have on a steam plant, the neater that it needs to be. You have to think it through before you start, and it's most important that the pipe runs follow each other where necessary. These are the steam inlet pipes to the engine, and they're going to be wrapped in string. I really can't wait to do that. In case you're watching thinking, well, it's alright for you, you know what you're doing. Well, yeah, I do. I've been doing it for a long time. And on the video, it looks really simple, but it isn't really simple in the slightest. I actually made two lengths that were unusable. They will be chopped up and put in my box of chopped up small lengths of copper pipe. I bent two pieces of this kind of pipe in entirely the wrong place, and once you've bent it, that's your lot. These tight bends really harden the copper. The only way to unbend it is to heat it to a red heat, and then you can unbend it. And this process is known as annealing. Some metals work harden, others don't, but copper work hardens very quickly. A word of caution: once you cut the initial piece of pipe to length, always clean up the end, because you will scratch your baseboard very badly if the ends of the copper pipe are sharp. It's vital to remove the burrs from the end of the pipes where they've been cut on the bandsaw. I normally do this on the belt sander, as you can see from the video currently running. There is one rule of silver soldering that must never be disregarded, and that is, always put the union nuts onto the pipe the right way round before soldering the union nipples on the end of the pipe. The first job that I'm doing is turning this piece of brass hexagon to make an adapter that fits on the burner. The trouble is, this brass is very soft, and far too much of the brass is sticking out of the chuck. And this, coupled with the fact that the cutting tool is fairly blunt, means that the brass just moves out of the way of the cutting tool, so you get a tapered shaft. Now I don't want this, I need it to be parallel. And as you can see, the finish on the shaft is dreadful. I'm doing this on purpose. Before any experts write in, I'm doing it for the purposes of the tutorial video. This clip shows me centre drilling the end of the brass, and now I'm going to use my live centre to support it while I turn the rest of it, and this time I'm going to do it more carefully. I still use the same blunt cutting tool, I do need to change that, but this is not a high tolerance component, so a little bit of roughness on the actual brass will be okay to grip the piece of silicone rubber pipe. This is a good tip. Quite a lot of the sensors that we have are quite useful, and hearing, for me particularly, has been very useful being a musician, but it's also useful for hearing when the tool is blunt, and if you listen to this, you will hear the squeaking, which is a sure sign that you're using a blunt cutting tool. Have a listen. And in case you're wondering why I mark the drill with a felt tip pen, it's so that I know how far the drill is going to go into the piece of brass. I only need the drill to go in as far as the end of the hexagon part. This clip shows me threading the part using a 1/4x40 threads per inch tap, after which I can fit the adapter to the gas burner. I use some Loctite 542 to seal the threads to make sure there are no leaks, and here I'm wiping off the surplus Loctite 542 with a cloth. I'm machining one side of a commercial steam union, and then I'm going to thread this side of the union 5/16 by 32 threads per inch. And here, as usual, I'm setting my micrometer using the drill shank of a 5/16 drill, and then I double check that this is okay by looking at the numbers on the handle. And now by using the micrometer I can get exactly the size that I need, which is 5/16 of an inch, to accept a thread, as I've just said, of 5/16 by 32 threads per inch. I made this adapter because I'm going to be using 1/4 inch pipe to connect the turret to the main manifold, and here's the pipe itself. In this clip I'm marking the pipe to length, and I cut this using the smaller of my two metal cutting bandsaws, and once I'd done that, it was time to silver solder these components to the pipe. These are the coned unions with their respective nuts, and I'm not forgetting to put the nut on the pipe before I silver solder it. And I can't believe it, all these years on, that I still forget to put the nut on the pipe first. Usually when I'm videoing the process, because I'm concentrating on the camera's focus and the angle and the lighting, and sometimes forgetting entirely that the nut needs to go on the pipe first. Anyway, here's the silver soldering process once again. The end of the pipe was coated in Easy Flow No. 2 silver solder flux, and this is not the flux that you would use for soft soldering, it is entirely different. Soft solder melts at a very low temperature, far too low for steam, but for really small steam toys like Mamods and Willescos, etc., which work at very low pressures and therefore very low steam temperature, soft solder is adequate. But for any steam boiler using a realistic steam pressure, which can be anything up to 100 pounds per square inch, soft soldering is absolutely out of the question. The temperature of the steam coming out of a boiler that is at 80 pounds per square inch is hot enough to melt the solder, because as the pressure rises, so does the temperature of the steam. Silver solder melts at a much higher temperature. So for any soldering application, other than on a very small steam toy, you need to learn how to silver solder. And the silver solder that I'm currently using is Silver Flow 55. In this clip you can see the silver solder flowing freely around the joint because the temperature is correct and the type of flux used is also correct. This clip shows me fitting the pipe from the valve on the boiler down to the turret. Thanks for watching, and I hope you found it useful.